Hello everyone. Today we are going to look at solar panel temperature management. Solar panel heating is a major issue in solar PV system. Many people complain about solar panel heating and which causes less efficiency of the panel and at the end the energy production or the power production is reduced. At the end the revenue is reduced. So you may see that some places solar panels burning or damaged because of overheat. So the reason is that solar panels are designed to produce a good amount of electricity at 25 degrees Celsius cell temperature. So 25 degrees Celsius is a typical cell temperature we want to keep. So it means like solar panels are designed to function at 25 degrees Celsius of cell temperature. But usually cell temperature reaches even 40-45 degrees Celsius because we are living in the hot country for let's say Sri Lanka, India and Asian countries. We get 30, 33, 35 degrees Celsius usual cases. So in that context, solar cells are even more heated than the environment, getting more. I mean, it consume heat and getting hotter and hotter compared to the environment. So there are many techniques we can adopt to reduce the heat effect on the solar panels because heating is one of the biggest problem. So we have to find the way. So these are a lot of research going on. So this topic is a research topics and we can simply implement it in our house and we can do research and come up with the idea how to reduce heating. So let's get into the slides. Okay, solar panel heating management is critical aspects optimizing the efficiency. So what we eventually want to do, want to optimize the efficiencies first thing. Okay, by optimizing the solar panel efficiency by reducing the heat, we can produce more electricity. At the end, it will be profitable to us if we do these changes. Okay, so excessive heat can reduce the energy efficiency and lifespan. Second thing is the lifespan, not only energy efficiency. If the panels are heated up most of the time, then the lifespan of the panel will be reduced. So 25 years long panel can die in 15 years time. Okay, so these are the things, lifespan. Okay, so usually 0.3 to 0.5 percentage the the efficiency drop for each degree Celsius above 25 degree. So that's why we are saying like 25 degrees Celsius is a typical. We want 25 degree, the panel's cell temperature. But if it is going higher, each degree there's a 0.3 to 0. Let's say 0.5 percentage of efficiency drop. So let's say these panels are now operating at 25 degrees Celsius, then almost 1 percentage efficiency dropped. So you can calculate 1 percentage your production will be dropped. 1 percentage of efficiency drop mean almost 1 percentage of production, electricity production will be dropped. That you can convert how much the cost losses, how much money will be lost because of heating. Okay, so there are basically two types of management system, temperature management system, that is active cooling and passive cooling. So let's look at one by one. The passive cooling system mean we are not going to install another system or another setup for that. We just do a small modification in the design, the solar PV system design, small modification. So naturally dissipate heat. So the concept is like by doing small changes in the solar panel installation setup, okay, where we install the panels, we are going to create the natural cooling environment. Like you might heard like the natural cooling buildings or natural the HVAC system in the house or in the construction sector, building sector. There are ways to cool the house in a natural way, like ventilation, putting the ventilation air in, air out. There are many ways. Similar to that, in solar PV system, we can naturally make the system cool by allowing the basically allowing the air to go from one way and come back another way. I mean, it's like giving the path for the air to flow. That air will remove the um, heat from the panel. So this is one of the things is elevated mounting. Panels mounted a few inches above roof or surface allow air to flow underneath, helping to cool the panel. So usually you might see this kind of panels. You might think that why they put little bit of height, like 2 feet or 3 feet. Why they put in the height? Why they put this kind of assembly? Like you might think that why these people spending money on installing this kind of setup? Yeah. So why they putting money to install this kind of these setup like the poles, small poles with a concrete or something. So the reason is the air can flow. You know, right, already that when the air can flow from this like a very small path, I mean, then this speed of the air will be high. You know, right? That usually air can enter here and come back here, or enter here, come back there, whatever way, uh, um, based on the air circulation. So if we are allowing air circulation through this path, okay, so mean below the panels we are allowing the air circulation. That will bring the cooling effect. You might stand there, you can feel the cool, because you know, right, when we block the air in somewhere and allow it to the another path, then the air will move faster through that path. It naturally happens. Okay, so here, if someone standing here, he can feel the little bit of cooling effect, because the air usually travel little faster in this area, so it will create the cooling effect. Okay, it's a air ventilation. Okay, simple. Then we use a tilt angle. We already have tilt angle things, because in order to get more solar radiation perpendicular to uh, the air, solar radiation has to fall in the panel in perpendicular to 90 degree to the panel. So then only we can get more energy production. But with that idea, we also need tilt angle to cool the panels. Okay, same thing, air can flow from here. It can get good cooling. Adjusting the tilt angle can improve the airflow around the panel and reduce the heat buildup. Optimal tilt varies by the location and season. Okay, so we can adjust the tilt angle based on if we need more cooling or less cooling, depend on the situation. Okay, okay, we can adjust the tilt angle and we get cooling effect. Okay, next one is a reflective coating. So applying coating to the back of the panel or surrounding surface can reflect heat away from the panels and reduce the temperature. There is a reflective coating, just painting like a reflective coated painting in the back of the panel. So the back of the panel will not absorb it, reflect the heat away. So this is the another method. It's very simple. Like these three methods will not disturb the installation. Like it won't impact the installation. It won't create much additional costs. Okay, just a design ideas, a little bit of changes in the design idea. That's why it's called passive cooling. Passive cooling means we are not really doing much changes. We are little bit of changes without affecting the system design, or majorly affecting this system design. That is a passive cooling. Let's look at active cooling. Active cooling method use additional system. That's the key. Additional system um, to cool the panels. So these you might see the research papers on this topic. I have seen the research paper when I review some research papers. I have seen these research papers because these are the research topics. They're doing a lot of researches. So water cooling system, air ventilation system, thermoelectric cooling system, phase change materials, use heat dissipation materials. So if you can find any material that dissipate heat, or you can find any technology that can remove heat from the panels, that's an innovation. Like you can get the pattern for that to your innovation ideas, and you can market as a product. You might see that in the early days, like laptops usually getting hotter. I mean, you can't keep the laptop in your leg or somewhere, so because it's getting hotter, so they come up with the cooling pads. You might see that the cooling maybe 10 years or 5 years before, the cooling pads for laptop is very famous. So you can see how the technology is developing. Now the cooling pads are not, I'm not seeing in much places, because laptop itself having a very good cooling. I mean, they produce with the laptop with less chances of heating up. So I can see my laptops I'm right now using, it's not getting heat. I'm using more than 8 hours a day. So the thing is that the technology changes, so the requirement of additional cooling is removed, I mean changed in this electronic industry. Similar to that, right now the solar panels are getting heated because of that because of environmental heat, and the panel cannot not able to remove the heat. So after 10 or 20 years, maybe they will come up with a very good solar panel material that will not get overheated. Okay, I mean that will always maintain 25 degrees Celsius of cell temperature. So the research idea here is, people are doing a lot of research on how to remove the heat from the solar panels, one thing, and how to improve the solar panel material so that solar panel will not get heated. Okay, two main areas. One is additional system, installing additional system to reduce the heating. Second one is changing the solar panel material so that solar panel will not heat it up. Okay, it's try to maintain at 25 degrees Celsius. So this is a very great area that many research going on. So you can produce a small research paper by using these kind of concept conference papers or anything. If you are studying, is simply you can do the research and do some changes in this water flow pattern or whatever thing. So it's simple. uh, Water cooling system. Water is circulated over the surface of the panel. You can see that the surface of the panel, water is circulated and collected here. So when the water is circulated, technically panel cannot be heated. So the heat will remove from the panel. Water cooling system can be combined with the water storage system. Okay, here, because every time you cannot put the water, so it's like the closed loop system. We have the tank here, so the water will go here and come back to the tank, something like this. Okay, if you put a small motor, the motor will pump the water, and water will return back to the tank. Okay, let's say you pump the water, so this is outlet, this is inlet. Okay, so you put the water here and get the water back. Okay, whatever way. So with very simple setup, you can do this kind of small setup, and you can get the power from the solar panel itself to run the motor. Okay, because then during the daytime, while solar panels are getting more solar radiation, during that time only solar panel going to get heated. So you can put small motor to pump the water, little bit of amount of water. That motor can work on the power generated by solar panels. You don't need to give a additional, I mean, the power outside. Okay, you can self sustain. This is called self sustainable. It can run itself from the power generated by solar panels. So that you can create this idea as a research paper, simple research paper, so that you can make small changes. When you do a research, you will come up with the idea to make small changes from what I am explaining. Okay, this is my purpose, like giving you more ideas about how we can do this um, to the next level of research and development. Okay, so the water cooling system, look at here, the small taps are there, water taps. They put small water taps. So whenever when you feel too much hot, or you can put the sensors in the solar panels and measure the temperature. If let's say it's going like 28 degrees to 30-degree more temperature, more heating, then you can turn off on the taps. So here it's look like a manual turning on. So you can put the automatic turning on also, like relay switches or something. You can, this is also one of the research, like whenever the, so you sense like a closed loop system, okay, you sense the temperature, okay, you measure the temperature and send this feedback signal to your computer or somewhere, mobile phone or something. Then this computer or controller, let's say controller will give a command to the taps to open. Tap mean command to the relay, so that relay will open the taps. See, look at this closed loop system, closed loop control system working here to make sure the water, the cooling system is working. The water cooling is functional, so that solar panel will not overheat it. So I'm spending a little bit of time and going a little slow here, because you can think about it and you can develop this as a research idea, conference paper, or you can come up with a product idea. Like you can put the tap setups. You can become a I'm a sub equipment providers, like when somebody installs solar panels, they have the heating issue, then they will contact you. We have a heating issue, can you come and settle our heating issue, or can you give a solution to that? Then what do, you go and install some kind of water cooling system or some kind of system, so that the heating issue will resolve. Then they will pay the money or the salary or some contract amount for you. So it's like a winter job. I mean, it's like what we say, the secondary market. Like someone installing the solar panels, there's a primary market. If you assume there is a primary market, installing a setup and everything running, and the secondary market means what to say, I am searching for the good word, like you become a line support man, or you become a person who support for the solar power production. Okay, you are helping them to improve the efficiency and making sure they get more benefit out of this. Okay. Okay, so then the air ventilation system. We can also put the air ventilation system like fans. We can put the fans, or even we can put the holes. Look at this. This purposely they make the changes on the panel setup, so that air can enter here and come back here. So these are the deliberate attempt to change the design of the panel. So that's why it's active cooling. So we put the fan and put the holes, then the air can flow from this inside, and the panel will be uh, cold. I mean the heat will be removed from the panel. Okay. Look at this here. That ventilation fan is placed. We can do this for the experiment purpose, and in the real installation also we can do in the large scale rooftop installation. Basically we can put this. Okay, this is for the experiment purpose. If you put the you can do the testing, like this is also small research topics, like okay, with fan how much power produced, without fan the how much power solar panels can produce. So just comparing these two things is itself is a research topic, research. Okay. So the last one is thermoelectric cooling. So thermoelectric devices absorb heat from the panel surface, transferring it away through semiconductor material. This is while more complex and costly. This is complex and costly. This system can maintain temperature even extremely hot days. Okay. So these systems, like if you install this kind of system, okay, that can reduce the heating, but it's costly. It's called thermoelectric cooling. Okay, we can install into the backside of the panel. Then these devices, this system will remove the heat, and making sure the solar panels operating in the 25 degrees Celsius. Okay. So what are the benefits of temperature management? Okay. Increase efficiency. By maintaining lower panel temperature, solar system produce more electricity. So definitely we need more electricity. Then only we can get more profit or more financial revenue from um, the project. Okay. So definitely we need to produce more electricity. So in order to produce more electricity, we need to increase the efficiency. The second one is a prolonged lifespan. Okay, because as I said, like if you don't let the panels to overheat, the lifespan will be increased. Anything, any device in your house or anything, if you maintain in a proper temperature, the life of the thing will be increased. Even your television or your computer, anything, if it is overheated, it will die soon. Okay, so this is the characteristic. Okay, that's a lifespan increase. High return on investment. As I said, if you do these kind of things, your return in investment will be increased. Okay, that's all for today. Thank you very much. So the reason is that to give you your idea and a research concept or ideas of cooling, solar panel cooling. Thank you very much. See you in the next video. Please subscribe this channel and continue giving your support.